Cool, yes. So I'm Connell. I'm the CTO at Zappar. I'll start with a very quick introduction to Zappar itself and talk a little bit about our Universal AR SDKs, which I think is the most relevant and interesting of our technologies today. And then I'm hoping to squeeze in a live demo as well. So fingers crossed that all goes well. So at Zappar, we've just turned 10 years old now, which is quite a lot of years in AR years. Our business is kind of split into two parts. We have our Zappar HQ team who consult with and build augmented reality experiences for some of the world's biggest brands and companies. And we have our content platform called ZapWorks, which enables many thousands of developers around the world to build and deploy AR content on their own. And indeed, it's ZapWorks that we'll talk a bit about today. So ZapWorks has lots of different tools and elements to it. From an AR content creation perspective, we have two bits I'd like to mention. Studio, which is our complete 3D development environment for building AR, VR, and MR. But most relevant to our conversation today is Universal AR, where we've taken all of our computer vision algorithms and wrapped them into SDKs for a variety of different creative tools and distribution platforms. What does that look like? It looks like this. So Universal AR lets you build tracked experiences. So that might be image tracked or face tracked or world tracked, which we'll see in a moment. And it lets you build them with the content platforms and libraries you're already used to. So Three.js and A-Frame on the web, Unity also supporting its WebGL output, and the SDKs for JavaScript and C++. And so in each of these cases, we make available an SDK which speaks the language of that platform. So if you're a Three.js developer, for example, our Universal AR SDKs, they provide a Three.js group for each of the different tracking types. So you understand as the Three.js developer how it fits within your ecosystem. And the same is true of the other examples. And what the Universal AR SDKs have in common across all of these is unprecedented support across browsers and indeed native platforms. So for example, if you're building a project with Unity, you can use Unity's Android or iOS build outputs, or indeed you can use Unity's WebGL build output to target face tracked, image tracked, world tracked AR experiences built with Unity to Chrome and Safari on iOS. And likewise, if you're building content with Three.js, you can target iOS and Chrome and Safari on iOS as well. Indeed, since this slide was prepared, we've already introduced another SDK to this list, which is React 3 Fiber. And so what that does, it's an open source project that lets you build Three.js experiences using React library. It makes for a really interesting way to build content, and indeed our live demo will use that. Also, just around the corner, we have two new SDKs as well, one for Babylon.js and one for Play Canvas. So really a large number of content platforms and libraries that you can leverage with these SDKs to build AR content. So a little bit about how our Universal AR SDKs work. So they support the versions of Chrome and Safari that have been running on your users' devices for years. And so they don't have to enable any experimental build flags or experimental browser flags, I should say, on your users' devices. It runs with the versions that are just installed and running there already. So we don't use the WebXR API. In fact, our computer vision algorithms run in WebAssembly in the browser using the camera frames and device motion data that are provided through the standard web APIs. So get user media, for example, and we use web workers and these other primitives that are part of the web standards. And we'll talk a little bit later about what the pros and cons are of that approach versus using an API like the WebXR API that's built into some browsers. Now, with Universal AR, you can track different things. So we have world tracking. That's where users can place content into the environment around them. So perhaps product visualization would let you place a pot into your table for you to see what it might look like in situ. We have image tracking. So that's when we have a a known target image, so a business card or a poster or a menu, for example, and being able to track that in 3D space and place content on or around that surface. And we have face tracking, so a bit like face filters, where you can attach content to the user's head. We have landmarks, so you can attach things, for example, to an ear if you were doing an earring or a mustache. Not that I need one, but to place it on your the top of your lip, and it would stay there. Or we also have what we call face mesh, and what that is it produces a surface that fits to your face and moves as your expression changes, and that fits the identity of your face. And so that would allow you to have, for example, a tattoo simulator or a face paint simulator. And often when we're building experiences using these technologies, we combine multiple of these technologies together to make really good experiences. So I thought before we went in any further, I'd give you a very quick demo just to show you it in action. So I'm going to see if I can switch which screen I am sharing. And I'm going to share instead. So I'm going to open up Visual Studio Code here. Let me just see that that's coming through correctly in the channel. There we go, perfect. So this is Visual Studio Code. It's a React project, a relatively standard React project where we're using React 3 Fiber that allows us to build 3D experiences using React. You can see here on the left, it's a really pretty standard structure of a React project. So it's a node project. We've got package.json that's got our dependencies in it. And in fact, if we pop in there, we'll see in our dependencies that Zappar's React 3 Fiber library is one of them. If I go to app.jsx, this is the root component for my project here. And where I suppose if you're used to React just HTML, you'd expect to see HTML here. We've got some components that wrap around a 3D canvas and the AR tracking primitives that we provide. So here we have a Zappar canvas component, and inside that, a Zappar camera component. If I was just using normal React 3 Fiber, that would be a 3JS camera if we wanted to expose the camera directly into our component like this. We have a light down here, which so we can see. And then we have our instant tracker. So this is our world tracking technology in universal AR. And in our React 3 Fiber example, it's just a component. And anything we place within this component will be tracked to the position that the user chooses when they're placing this content in the experience as they have it. And that will become more clear in a moment. I'll show you the process of what this looks like for the user. But in this case, we're placing into this instant tracker a mesh. It's a sphere, and we're giving it a bit of hot pink material so that it has a little bit of visual interest for us. It's going to be just a simple sphere, so I don't think we're going to win any awards for the content, but it should hopefully demonstrate how easy it is to get some content into a world-tracked environment. Now we have a few extra arguments and parameters passed to our instant tracker. What they're doing is letting the user, or letting us configure for the user the placement experience. So how the user chooses where to put the object in space. And we'll see that in a moment when we try the experience. The content starts being in the center of the camera and will allow us to choose a location in space. There's a button on screen, which is in fact this div component down here. And when I tap on that as a user, that lets me say, this is where I want to place that content. So without any further ado, let's see it in action. Now, because this is a standard React web project, I'm using, I think React, I'm trying to click the wrong place. I think the React scripts to, React app rewired to host this in a development environment. So I think it ends up being Webpack behind the scenes. It gives me, in fact, if I just close that, I just go npm run start. That gives me URL that is running on my local network that I can use to test the experience as I'm running it. So let me switch over to device. That involves another screen share change. So I have a iPhone XR, in fact, here, and it's relatively standard XR from a couple of years ago. So nothing special, particularly in its features or functions. And if I switch over to here, hopefully we will be able to see it. So I've got it attached to my computer just for the purposes of being able to share the screen of the phone. I'm going to reload this page. So this is the page that's being hosted by that script I'm running in Visual Studio Code. Universal AR provides a standard permission prompt so that users can grant the necessary permissions, which are camera and motion data, to the page so that it can perform the AR experience. But this is all configurable and customizable. So because I haven't specifically in my project changed this, I'm getting the standard one, which fits in lots of circumstances. So I'm going to say grant access. And here we are in my room. This is just the table in front of me. And I've got some content that I'm going to place here. And there's that div at the bottom of the screen allowing me to tap to place that object. And when I tap that, the object now stays rooted to the spot tracked in the world in front of me from the point I've selected. Now, I should say that, and this doesn't always come across well on screen shares, but from my perspective, this is running on the phone at full frame rate. So we get 60 frames per second from the camera, and we're rendering at least 30 frames per second in terms of the content. So it feels really smooth to me. At Zappar, we have a little joke that the experience is a buttery smooth and that it can't believe it's not native. So it's got to feel like I'm using a native app in terms of performance, which it does in this case. Cool. So I'm going to show you another quick example when I'm here. So I've got some examples from our website. So this one is a face tracked example. I'm just going to load it from a QR code. This one's built in Unity, which is a really nice way to build AR content for the web, it turns out. Let me just try reloading. Here we go. Made with Unity. And in this case, it's a face tracked experience. So let's grant access. Here we go. And it's just some simple 3D models attached to my head. But as you can see, like the tracking is super solid. Like it's really low latency. And yeah, pretty astonishing that it's running just in the web browser without any native help. Cool. Okay, so let's switch back to the presentation. And I think it's this one here. One second. There we go. And so I thought I would talk a little bit about the pros and cons of our universal AR technology versus using something like the WebXR API, because the approaches are quite different and each have their own pros and each have their own cons. So with universal AR, as I mentioned before, it all takes place in the web browser using WebAssembly and the other primitives that are provided as standard in the web browser, rather than the WebXR API, which we'll see in a moment, leverages the underlying frameworks as part of the operating system. So anyway, universal AR, it has more tracking types and computer vision algorithms than WebXR. And indeed, we're able to add new features and new tracking types very quickly to universal AR, and those be supported in all of our supported browsers without requiring those browser updates. And that's because the technology is just running in the web page. So if we have a new computer vision algorithm we want to deploy, we just add it to the library. We have full control over the camera and the camera frame rendering as a content developer when using universal AR, and that enables you to have more effects and filters. So as I say, it works as just a normal WebGL canvas, and it plays nicely with other HTML and CSS. So with universal AR, your HTML and CSS are not on a separate layer or in a kind of special layer in front of a camera like it is with WebXR. It's just a normal part of the 3D rendering of your experience. And that gives you ultimate flexibility for what you do with the camera and how you process it. We support multiple different camera sources. So what that means is you can process video elements such as live streams and perform the AR calculations on those, or indeed you can process the camera stream from another device if you wish, rather than just using the built-in camera on the device. And we should support both the shipping and older versions of mainstream browsers without any special feature flags, including Safari on iOS, Chrome for Android, and indeed now Chrome for iOS, Firefox, Chromium, and Blink-based browsers. And that's because pretty much all of these browsers support those core APIs of WebAssembly, web workers that we're able to rely on to work this technology and make it fast and feasible to run in a mobile web browser. And indeed, we can support devices that don't have ARKit and ARCore, which I suppose are the iOS and Android equivalent underlying frameworks that power WebXR through those platforms. And indeed, that includes desktop browsers, but also Android phones, for example, that don't have Google Play services, such as the devices that are popular in China. Now, on the other hand, WebXR has some advantages. So the tracking algorithms that WebXR exposes leverage those OS-level provided frameworks, so ARKit and ARCore. And what that means is they get access to native performance. So all of those fancy chips in your iOS device that can, I think they call it the neural engine, perhaps, that can perform lots of machine learning, computer vision technology, or indeed the fancy cameras like the depth camera on those higher-end iOS devices. ARKit, for example, can leverage those, and thus WebXR gets the benefit of them by proxy. And they get lower-level access to the hardware, which means, for example, that ARKit and ARCore are able to tie together data from the gyroscope and from the camera in a really closely knit and well synchronized way, whereas in the browser, we just don't at the moment get access to all of those APIs that allow us to access that data in the same way. Now, as you can see from our examples, you can still do a heck of a lot without those low-level hardware access elements, but it does mean that you're going to get the best native performance from WebXR as a result. So with WebXR, there's no licensing requirements. It's a technology that is embedded into the browsers, and so you can just use it freely as you would any other API in the browser. With Universal AR, you have a Zappar subscription with us to authorize your use of the Universal AR SDKs. For hobbyists, we offer that for free, so you can be building content without it costing anything. And for businesses, we have a monthly subscription that you pay, and that at the end of the day pays our engineers basically to continue working on this technology. And indeed, with your subscription, you get access to all of our tools and hosting and a number of other benefits.
Hey, Connell, I'm afraid I'm going to need to interrupt. Thank you so much. Okay. We actually have some questions from the audience, if you wouldn't mind taking one or two.
Yeah, no, of course, we'd love to.
That's great. Yep, let's see here. Let me make my screen a little bit bigger so that I can read it. Okay, so I know the Zappar glasses had their go on Kickstarter. Do you think the web will be a part of the roadmap for Universal AR?
That's a good question, and there's a few different bits here. So Zapbox is our headset that we're building at Zappar. We've had previous versions of Zapbox made out of cardboard. The next version of Zapbox, which we've just, I think at the end of last year, had on Kickstarter, is made out of plastic, has 2 active controllers, but comes in at a sort of sub $60 price point, so way cheaper than other headsets. It will, in the first instance, be natively supported through apps built, for example, through Unity for iOS or Android. The reason for that is in order for us to do the computer vision elements that we need to do. We would need to, I suppose, be a provider for WebXR in that sense. And since we don't have access to the to be able to, I suppose, implement Chrome or Safari and hook them in that way, it's difficult for us to support the web for Zapbox. That said, with our Universal AR SDKs, those SDKs target AR for mobile handsets. So, like you're holding like this rather than for the headset, and they support the web as a first-class citizen, and it works really well there.
Great, thank you so much. I think it's really interesting to see platforms like Zappar that mix both web access and native access into a single platform. I mean, obviously, for a lot of customers, the goal is to reach as many people as possible, and in some ways it doesn't matter to them which distribution pathway they take. So I think it's interesting that that you've built something that has both of those as sort of part of the core idea. They're not distinct.
Yeah, I think part of that for us, our technology has been built in a way that means we can deploy it in these different ways, which I suppose I'd like to say we'd planned from the start, but actually is just a kind of happy accident of the fact that we were building this technology for very constrained devices in the past, and it means that it works well in the web now. We see an increasing use of the web for AR content, and the benefit of not having to publish and host an app in an app store, it really makes a big difference for lots of AR use cases. But we work with some fantastic businesses who have great app ecosystems, and that they seek to boost those ecosystems with AR content, and get the mutual benefit of hosting that content within their app ecosystem. So, for example, 7-Eleven in the States, we power an always-on AR campaign with them, and so in their 7 Rewards app, there's always AR content to be had. And that content in the future they might wish to deliver through the web, and we'd have that option available to us. And indeed, users of Zapworks have both those options available to them also.
Yeah, I think it's a interesting and I think somewhat unique within the context of this conversation. So I'm glad that you've been able to be here today, and thank you for being a part of this event.
Thank you so much for having me. It's been a pleasure.